Alright, so this video is going to be the first video in um, discussing topics in Chapter 2, the first chapter that we'll be covering in your book. I'm not sure how long this is going to be with the 15-minute time limit, but I'm guessing there's probably going to be about 2 videos for this topic. In this video, I hope to discuss the following topics. I hope to discuss displacement, let's see. I hope to discuss average velocity. I want to discuss average speed. I want to discuss instantaneous velocity. And there's some calculus involved with that. Let me just put that just for the fun of it. Calculus. And I hope to discuss acceleration. And in particular, one special case, constant acceleration. And you probably remember this from a few years ago as kinematics, or using the kinematics equations. So I'll show you those, and that should about do it for this video. Sound like a plan? All right. So let's go to the next slide. Yeah, like that. All right. Oh, I guess I'm on the last slide. Let's view browsers. Let's go back up here. Okay. So, starting off with displacement. Displacement, let's get a good color here. Displacement is, you can think of it symbolically as the change in your x position, or your final x position minus your initial x position. Alright? So, so you start here at this point, we call this x initial, and then you move something like this. And you end up here. In terms of just displacement, none of this matters. This is your distance traveled. Your displacement is going to be, is that a good color? I didn't even change colors. This is your displacement here, this straight line distance from here to here. Alright? This is your delta x. But displacement happens to be a vector quantity. And that means it has size, or you can think of it as amount of something, or magnitude is the kind of the proper word. In addition to that, it has direction. Direction. So, in this case, let me actually, with a direction, it's useful to represent it with an arrow. ugly. So size-wise, this is, I don't know, 2 centimeters according to my screen roughly, and the direction is to the left. But what if we took a path like this instead? Starting here, and we went, yeah, right here. That's our X final. Now, it looks like we went about the same magnitude or distance, but what's changed is the direction. Now we're going up. So displacement has direction and size. All right. The next term that was on my list was average velocity. And essentially this is how fast is my change in position. Symbolically, we can write that as V average equals change in position over the change in time. Or, as we wrote this before, x final minus x initial. And now the change in time is going to be time final minus time initial. All right. What would this look like? Let's put a little graph over here. And we'll just draw a curve that looks like this. Whoa. All right. Let's start here and let's end here. So in position wise, this is our x initial and this is our x final. Time wise, here is our time initial and here is our time final, right? Just basically lining them up here like that. So you find these values on your graph and you subtract them and you get your average velocity. Should kind of look familiar to you if you, let's see here, did that work? Yeah. If you, whoa, that's interesting. Don't want to do that. If you connect these dots with a line, you basically get a rise over run slope, and the rise is x final minus x initial, and the run is t final minus t initial. All right. So the average velocity is the slope of this line. Let's go back to, oops, good old pen here. Slope of this insane of this line. Right here. All right. The other term I want to talk about was average speed. Speed is different from velocity. Velocity is a vector. It shows you how fast you're going and in what direction. In this case, the direction you're moving is up on the this axis, which is typically the y-axis, but this is a term called average speed. it's basically the total distance over your change in time. Often seen, by the way, more familiarly as S equals d over t. All right. Now let's do an interesting little graph over here. We'll put this graph in meters, and this is in seconds. Let's say something moves along the x-axis up, and then slows down, stops, and then turns around and goes back down the x-axis. All right. Here's 0. Let's say it takes 10 seconds. I think I'm getting close to my edge here. I'm going to put this is 10 seconds here. And up here is 50 meters. Now, for average, let's go in order. Oops. For average velocity up here, it's your change in position over your change in time. But what's your change in position? Your initial position here is at 0. Yes, you do go up to 50, but your final position is back down at 0. So if you plug in 0 here and 0 here, your average speed, V average, your V average is 0 meters per second. On the other hand, your average speed, which is your total distance traveled over the time, that's different because your total distance, first you move up 50 meters, so you've gone 50, stop, then you turn around and go back 50 meters, so you travel a total right here of 100, so that's 50 plus 50 over the change in time is 10 seconds. So 100 divided by 10 is 10 meters per second. And that's your average, whoa, stop. I'm going to figure this thing out someday. Your average speed. And it looks like I am getting close to the 15-minute mark, so I think I'm actually going to stop this video here and put instantaneous velocity, acceleration, and constant acceleration on a second video.